All right, now that you've solved by substitution and you've solved by graphing, now we're going to solve by elimination. Sometimes they call it linear combinations. Sometimes they call it elimination. Whatever it is, the rule is the x, the y, the equal, and the number have to be lined up in order for you to be solved by elimination. If you look, I actually set everything up for you. I even set up number 15. I just did it backwards, where I did the y, then the x, then the equals, then the number. So what I want you to see is if I had 3x minus 7y equals 8, and I had y equals 4x plus 9, nothing even is lined up. So if I wanted to solve this by elimination, I would have to put this in standard form, which means I would have to move this over to that side. If I did that, I would subtract 4x and subtract 4x, and I'd end up with negative 4x plus y equals 9, x, y equals a number. Now it's lined up so that I can solve by elimination or linear combination. Again, the homework assignment is already set up for you. Now I want to point out, before I even get into this, I need you to get, if I had you solve this one by elimination, you would get an answer. If I had you solve this one by substitution, the answer should be exactly the same. If I had you graph it, the answer should be exactly the same. Okay? So let's actually start with number 4. Might as well. So the great thing about elimination is all about eliminating. So if you can make something go away, things are going to be easier. You solve by elimination by adding. So always look to see, you're going to add them just vertically and see if something goes away. So let's look. 4x plus 2x, 6x. Nothing went away. But if I go 3 minus 3, or 3 plus a negative 3, something gets eliminated. That means it is perfectly conducive for solve by elimination because this got eliminated. Okay? So let me zoom in a little bit, and then you divide by 6, x equals 4. You got the x value, now you have to find the y value. Now, in the other section, finding the other value was a lot easier because it wasn't in standard form. In standard form, it's a little bit more difficult. So pick the first one or the second one. You might like the second one because the numbers are smaller, but I like the first one because it's all positive. So I prefer to plug the 4 into this x. You could plug it into that one and it should still work. So I'm going to go 4 times 4 plus 3y equals 16. So I took this same equation, and instead of writing my x value, I put 4. Now I just solve. Anything divided by 0 is 0. Now before I circle it, I'm going to check it. 2 times 4 is 8. Anything times 0 is 0. 8 plus 0 is 8. 4 times 4 is 16. Anything times 0 is 0. So I know that I'm good to go on both of them, so I'm done. Okay, let's do another one. Well, let's look at number 2. Number 2 is a little bit different. This had an x and a y. This has an m and an n. Who cares? First comes m in the alphabet. Second comes n. So this is like an x, and this is like a y. Don't get intimidated. Now, some of you think, when I add, that the m's go away, but they wouldn't go away because m plus m, well, you have one m, and you have one m, so it doesn't go away, and it's actually 2m. But then if you look, 2 plus negative 2, yes, my n got eliminated. It becomes a lot easier to solve. Divide by 2, m equals 7. I have my m, now I need to plug it in to get my n. You can pick the second one, but there's a negative. I don't like negatives, so I'm going to pick the first one. I take the 7, I'm going to plug it in for my m. So I'm going to go 7 plus 2n equals 8. So there's my m being plugged in. Subtract 7, 2n equals 1, divide by 2, n equals 1 half. Okay? So before I have the answer, 7 comma 1 half. Before I circle it, I'm going to plug it in. So I plug in 7 for m, so that's 7. Minus 2 times a half. Well, half of 2 is 1. 7 minus 1 is 6. Check. m is 7. Half of 2 is 1. 7 plus 1 is 8. Now I know that I'm good to go. Okay. What happens if this time, let's look at number 10. If I add in number 10, there's a problem. Because if I add, I get 7x minus 10y. I didn't eliminate anything, but I like elimination. Honestly, I think a lot of you are going to like elimination the best, and that's fine. But it's not working the way it's set up right now, so what I need to do is manipulate it to make it work. I think the easiest way to do it is whatever the second guy is, give it to the first guy for the x. Whatever the first x is, I give it to the second. So whatever this guy is, I give it to the first. Whatever this guy is, I give it to the second. Because what's 4 times 3? 12. What's 3 times 4? 12. So I get 12 both times, but if I added that, it wouldn't go away, which means one of them has to be negative. Doesn't matter which one's negative, you pick. I'll just pick the top because I feel like it. Okay? So once I do that, I have to multiply the negative 4 to all three of them, or I'm not the same. Therefore, my new equation is going to be negative 12x, negative times a negative, plus 4y equals negative 40. That is my new top equation. I know that's kind of small, I apologize. And then I've got to multiply it here. 1, 2, 3. 12x minus 27y equals negative 6. Now, when I add to eliminate, boom, the x is gone. That makes me happy. 4 minus 27 is negative 23y, and negative 40 and negative 6 is negative 46. Divide by negative 23. Y equals 2. I got my y value. Now I need to get my x value. So I'm going to plug it in. The problem is they're both negative. That doesn't make me happy. But then this one is also negative, so I actually think I'm going to pick the first one. So I'm going to take my 2, and I'm going to plug it in for my y. So now I'm going to write 3x minus 2 equals 10. So there's my y. Plugged it right in there. I could put parentheses in there, but it's just a positive number, so I don't want to. Plus 2, 3x equals 12, x equals 4. So I have 4 comma 2, and you know me. Before I circle my answer, I have to check. 3 times 4 is 12. 12 minus 2 is 10. Check. 4 times 4 is 16. 9 minus 2 is 18. 16 minus 18 is negative 2. So now I know that I'm good to go. Now I would like to point out, I'm going to write down the exact same equation because I know some of you learned it a different way. Some of you might have gone, hey, honestly, it's just easier if I multiply this by negative 9 and that's it. Multiply, sorry you can't see. So I rewrote the original equation. I know that some of you see that maybe x wasn't easiest. You could have just multiplied negative 9 to the first one, gotten negative 27x plus 9y equals negative 90, and just eliminated the y. Sorry about that. So I multiplied, let me back this up a little bit, sorry. I just multiplied to get the y. Now when I add them, the y gets eliminated this time. I get negative 23x equals negative 92. When I divide, x equals 4. Well, if you look, that's what I also got. If you can see multiplying only one equation by negative 9, do that. If it's just easier to always look at the x, and whatever the second guy is, give it to the first, and whatever the first guy is, give it to the second, do that. Okay? I'm going to do one more example, and then you'll do the rest for homework. So I'm going to do number 11, but because I made some space over here, I'm going to get a whole new piece of paper, and I'm going to rewrite the problem so there's space. Okay, this is my number 11. I want to be clear, so now I'm going to walk away from this. So I taught you that whatever the second guy is, give it to the first guy. And whatever the first guy is, give it to the second guy. But the problem is that a negative times a negative is a positive, and a negative times a negative is a positive. So they end up being exactly the same. But you want one of them to be an opposite. Well, you don't give two negatives, because then really if you give two negatives, that's just a positive. So now, if this is a positive 3 times a negative x, I end up with negative 3x. And then positive 3 times, let's make sure that's positive, that didn't erase very well, negative 15. Anything times 0 is 0. Now a negative times a negative is a positive, and look, I can eliminate. Plus 10y equals 10. Now I'm going to add to eliminate. I get 5y equals 10. Divide by 5. Y equals 2. Now that I have my y, I'm going to plug it back into my original and get my x. I like that that equals 0, so I'm just going to plug it into the first one. It's interesting that that ends up working out. So now I'm going to go negative x minus 5 times 2 equals 0. Negative x minus 10 equals 0. Add 10. 0 plus 10 is 10. There's an imaginary negative 1. Divide by negative 1. X equals negative 10. I feel like my answer is right. But before I circle it, I better plug it in. Negative of negative 10 is positive 10. 5 times 2 is 10. 10 minus 10 is 0. Good. Negative 3 times negative 10 is 30. 10 times 2 is 20. Negative 30, wait, something happened. I think I made a mistake then. Nope. Wait. Pause. So I paused it and checked it and realized I made a mistake. I love that I made that mistake because now I can show you what happens. Negative 3 times negative 10 is positive 30. Negative 10 times 2 is negative 20. 30 minus 20 is 10, but what did I get? Negative 10. Now I see what my issue is, and here's where I made the mistake. Negative 15 plus 10 is negative 5. So that should have been a negative 2, which means that should have been negative, which means that should have been positive, and this should be minus 10, which is negative. Now that's positive, and that's negative. Hopefully that made some sense. That's why it's so good to check your answers. I love that I made that mistake. So now I think the answer is 10 comma negative 2. Start again. Negative 10. Negative times a negative is a positive. Negative 10 plus 10 is 0. Check. Negative 3 times 10 is negative 30. A negative times a negative is a positive. Negative 30 plus 20 is negative 10. Now I'm good. Careful of those mistakes. Okay? Now I would like to say, I'm going to write down the original problem again. Some of you might have just gone, hey, Miss Rifkin, why didn't you just multiply the first guy by negative 2? And if you would have done that, then you would have seen that these two, cross off that now, can just be eliminated. You're left with negative x equals negative 10, x equals 10. If that's what you want to do, that's great. But I think the easiest thing is whatever the x is, whatever the second guy is, give it to the first. Whatever the first guy is, give it to the second, and then make sure they're opposite. Okay? One more thing I need to go over. It's maybe on there, but maybe it's not. If you have 3x minus 7y equals 10, negative 3x plus 7y equals 4. If I add them to eliminate, everything's gone, so I'm left with 0 equals 14. Can 0 ever equal 14? Never, not even on a Tuesday. So that would be no solution. They never touch. If you graphed it, that's what it would look like. Okay? If I had the same thing, but this time I have 3x minus 7y equals 10, and negative 3x plus 7y equals negative 10, and I add them up, gone, gone, everything's gone. 0 equals 0. How often does 0 equal 0? Every day of the week. That would be infinite solutions, which means if you graphed it, it would be the exact same line. Okay? Careful of those things. Your homework is to finish the page.